Hello and welcome to the first video on the Save My STEM Physics channel. This is a channel run by a current Year 12 physics student who does physics, maths, further maths and chemistry. This channel is being set up so that I can aid my other physics students in case there's any understanding that you're missing. In case you're looking for any exam questions, this unfortunately won't be the channel for you. This channel is here so that you can catch up on any understanding you may be lacking in case maybe you're a future student and you want to get ahead in some learning. Uh, and yeah, so uh, we will just get on with our first lesson, which is the SI units and derived units. Okay, to start off with, we are going to do our SI units. SI stands for System International, well, the French version of it. Um, but I don't speak French, so we're just gonna roll with that. System International, and it's just units. So there are 7 base units, which are, accepted units for physics calculations and quantities and properties in physics, um, which are mass, so the measure of the amount of matter in a substance or object or compound or whatever. That is measured in kilograms for your calculations in physics with the symbol kg. You have length, which is the distance between 2 points. That is meters with a symbol m, if I can sort my handwriting out. You have um, this is quite a random order if I'm frank. You have amount of substance, which is more for chemistry than physics, but it is in moles, which many of you will have encountered at GCSE. It's temperature, which is, the average internal energy within a substance. So that is measured in Kelvin with a symbol of K. Kelvin, importantly, is degrees Celsius plus 273. So let's say I have 25 degrees Celsius, that would be equivalent to 298 Kelvin, 25 plus 273. Our next SI unit is time, which is in seconds. Don't really know how to describe time. It's just time, isn't it? Uh, there is current, which will come into play a lot more when we get to electricity as a topic, as a chapter. What the hell is going on with the light? Oh God, that's going to give someone a seizure. Anyway, uh, the quality will improve as I go on, but yeah. So current is measured in amps. It is the rate of flow of charge. Well, it's amperes, but yeah, amps is acceptable, and the unit is A. Um, Strangely enough, in calculations, it will be given as I. Similar to length, if there's a displacement, it is S, which comes from the Greek word for space, which my friend actually searched up today in physics. And then the last one, the useless one, which you won't even have to remember, is luminosity, measured in candela, and that is a measure of brightness. It has the symbol CD, like compact disc. So those are your SI units, those are your base units. So if I just get on the side here, base, there are now derived units as well. So let's say I have the Newton. The Newton is a measure of force. What you'll notice here is the Newton is not a base unit. So how would I write it in terms of base units. Now, this is something you've probably already studied, but we are going to use equations that we are given in our equation booklet. The easiest one for newtons, newtons is a measure of force, so we know we're going to have an equation using force, and then we're going to use we're going to use an equation using force and have it equal to something which we can derive. So F equals ma, Newton's second law. We can therefore say that newtons equals mass, kilograms, times by acceleration is delta velocity over delta t, so change in velocity per unit time. Delta velocity is change in displacement over change in time. So we can say that acceleration is change in displacement per unit time squared. So we can therefore say newtons equals kilograms per meter, because that's our measurement for displacement. And then we have time squared, km s to the minus 2, because that minus is just basically the same as doing over. So that will give you your value of kilogram meters per second squared, and that is the derived unit for newtons. The same logic applies for all other units. So let's say I wanted to do joules. I'm just going to split my page in half there. Should we actually do joules? Yeah, we'll do joules. So we'll do kinetic energy, energy being measured in joules, equals a half mv squared. Joules, because that's, our kinetic energy, equals the half is constant, so we can ignore that. And mass, we've already seen, is kilograms. And velocity squared is change in distance, so meters, over change in time, which is seconds squared. Okay, yeah. And joules equals kilogram meters squared per second squared. Sorry, I got a little bit tripped up for a second there. But that is our lesson on base and derived SI units.